Before we go any further, we need to talk about how multi-architecture works. We praise Docker as a tool that facilitates the deployment of applications over multiple environments. You can write a simple Python or JavaScript application, package it as a container using a Docker file, build the container image, and voila! Your image runs in a reproducible way on all the machines where Docker is installed. However, what has been hidden is that this image will only work on the machines that support the architecture it was built for. Building an image is like compiling a C program. If you compile your code for a Linux system, then the resulting executable will only run on Linux machines, and the same goes for Windows and macOS. Building images is technically the same, and it essentially boils down to the same compiling story, though I won't be going into further details here. The idea is that if you build an image on a certain architecture, x86, ARM, and you name it, then your image will only run on that architecture. So how do we achieve multi-architecture support then? We build on all architectures. For that, you need to have physical access to the target architectures. For our case, we will be using x86, IBM Power, and IBM Z systems. The second step will be to build images. I chose Docker for this, but you can use any container tool as long as it is OCI compliant. At this point, we should have 3 separate images, one for x86, one for IBM Power, and one for IBM Z. What we can do now is push these images onto an image registry. Although the images are built on different architectures, this is still possible because they won't be running there. The image registry serves only as a store for our images, or artifacts. However, if a user wants to use my application, he has to deploy the right container image according to the architecture he wants to run, and that can be annoying. To simplify the deployment process, the last step here will be to use what we call a manifest file. The purpose of this file is to abstract away the architecture of the images. The end result is going to be one single manifest file that points to the 3 images that we have built. And each time a user tries to pull an image using the manifest file, it will try to figure out the correct image to use based on the user's architecture. This manifest file can be pushed to any public container registry, like Docker Hub or Quay, or even private registries such as IBM Container Registry, and can be used just like any regular image to pull container images. Now, I have tried to be as concise as possible, but if you wish to know more, you can check out this techzone collection that goes more in depth into the multi-architecture support for containers, link in the resources section.